Hi, and good days. My name is Emily C. Let's move to the introductions and objective for this project. This project focuses on redesign the Toyota Automotive plant to improve operational efficiency through systematic facility planning. The existing layout has several efficiencies, including long material travel distance and production bottlenecks. Therefore, a new facility layout is proposed using lean manufacturing principles to reduce handling costs, improve workflow, and maximize space utilizations. The main objectives are to minimize material handling distance, enhance employee welfare facilities, and eliminate bottlenecks to improve overall plant product.
Okay, so this is the layout factory that we've chosen for the automotive topic. This is the Toyota factory layout plan. As you can see, there's three different colors and numbers that represent, for example, red represent parts fabrication and surface treatment, blue represent main assembly, and green represent quality control and finishing. And the numbers is representing the step by step for each process. So now we move on to the process flow. As I said before, in the layout plan, there are three main processes that I have labeled with three different colors. So for the red color, we start off with the forge process to stamping process up until the body assembly factory. And then for the blue process, we start with part storage area, and then we move to engine, body part, and chassis, and then they will be assembled at the body assembly factory, and then they will be checked by the quality inspector at the outsourced product inspection area. They move on to service station, and lastly, they are ready to be posted out from the factory at the guard station.
Now I want to present about pillar tables, which stand for facts, ideas, premium. First, we identify several problems in the factory layout. For example, cafeteria for workers to take a break, no designated emergency assembly, no prayer room, no medical center, and also no dedicated training space. We propose several improvements such as adding a cafeteria, emergency prayer room, and medical center, and also training center. Then is the learning issues, which are the questions we need to answer before finalizing the design. We studied the required cafeteria size, emergency safety tracking guidelines for a prayer room, um, and others. We carry out the actions, including researching standards, calculating the number of estimating space requirements, and referring to OSHA and other related. So these findings helps us develop a factory layout for is safer, more comfortable, and suitable for the workers.
So this is the activity relationship table. It represents the closeness and the importance of each process to one another. So for example, as you can see, the forge process and the stamping process have a closeness rating of A and 1. A represent the absolute necessary, and 1 represent the frequency of use is high. So does show that forge and stamping process need to be next to each other for the layout plan. So it will be a lot easier and reduce the transportation time between the process.
Now we move to this slide, which is this table shows the personal requirements for non-work areas in our factory. We identified the facilities needed, including a cafeteria, car park, player room, health services, locker room, and restrooms. For each facility, we refer to relevant guidelines to determine the required features and estimated space size. These facilities help improve workers' comfort, safety, and welfare while ensuring the factory meets standard workplace requirements. This table shows the personnel requirements for the work areas in our factory. It includes the main production department, such as material preparation, body assembly, paint shop, material handling, maintenance, final assembly, and also quality control. For each department, We identify its main functions, estimate workforce, and operational requirements. This information helps us to determine the appropriate layout, space allocations, and workflow to ensure an efficient and safe productions process.
Based on the proposed production flow, a suitable material handling system was developed to support efficient movement of material throughout the plants. Different equipment was selected according to operational requirements, including AGV, conveyor overhead hose, forklifts, and reach trucks. The proposed system achieved a total travel distance of 570 meters, a handling time of 90 minutes, and a handling cost of RM59.25 per production cycles. In addition, the MO ratio of 1.27 and the MCE of 50% indicate an efficiency material handling system that support lean. After establishing the material handling system, the facility layout was optimized using systematic layout plannings together with the graph-based agencies and the pairwise exchange methods. The redesigned layout creates a continuous one-way production flow by replacing closely related departments next to each other. As a result, the material handling cost was reduced by 43.3% from 820 to 465 cost unit. The layout also eliminate backtrackings, minimize cross traffic, and reserve an expansion area to support further production growth.
Moving on to the next chapter, there is warehouse operations. So the objective is to ensure efficient material flow, minimize inventory costs, and support continuous production through systematic warehouse management. So there are several functions, that is to receiving, storage, material supply, and shipping. So the key for the improvement is we need to touch the warehouse management, inventory tracking, separate receiving and shipping, inventory classification, cross-docking fast-moving parts, and material transport. So this we summarize with the purpose. Warehouse system improve logistic efficiency by integrating WMS, RFID, optimized storage, and lean material flow, supporting continuous automotive production. So, moving on to manufacturing systems. So, the objective is to develop an integrated manufacturing system that improve production efficiency through automation, lean manufacturing, and Industry 4.0 technologies. So, there are several systems that include automation, FMS, multi-machine system, WIP reduction, and just-in-time. Okay, so the expected improvement we get here is to faster production cycle, lower work in process inventory, reduce material handling, higher product quality, lower manufacturing costs, and higher production efficiency. So the purpose of manufacturing system is to integrate automation, just-in-time production, and inventory technologies to achieve continuous production flow, higher productivity, lower operational costs, and improve product quality.
So next, I will present the proposed facility system for Toyota manufacturing plant. So facility system are essential because they support continuous manufacturing operations while ensuring workplace safety and employee comfort. So there are several key for the facility system, which are including the structural system, ventilation and enclosure, electrical and lighting, building automation system or we call it BAS, maintenance management, life safety system, and supporting facility. Finally, in chapter 10, evaluate the effectiveness of the proposed facility layout using quantitative method. The key parameters include a travel distance of 170 meters, material handling time of 90 minutes, and MO ratio of 1.27 and a manufacturing cycle ratio of 50%. The evaluation was carried out using from two chart, pairwise action method, and graph-based method. Overall, the results show improved material flow, reduced transportation distance, and high operation efficiency. Therefore, the proposed layout performed better than the original layout and support lean manufacturing principle.